PHIUS Plus 2021 Passive Building Standard. Next slide, please. All right, so what PHIUS Plus does as a passive building standard, it requires design for low heating and cooling loads, peak and annual. That's kind of the distinguishing feature of passive standards. But it also addresses overall energy use and requires quality construction. So switching the order a little bit, we did come up, our major updates for 2021, we did come up with a non-residential quality assurance protocol. And we also made a number of moves on the overall energy front to encourage net zero design and electrification. And then we came up with this prescriptive path for single family residential. So I'll just get the first of those, touch on the first two of those first here. And so the new quality assurance protocol works for all non-residential buildings and for mixed use buildings. And there's a great big workbook for that. Next slide. Okay, so on the overall source energy front, basically the idea is to accelerate the glide path to net zero. And so we're also, so for our source zero tier of certification, we're also going to get rid of any fossil fuel combustion appliance on site. This, as many of you may know, we sort of took the same view that Architecture 2030 did, that things should be net zero, and that there's only so much you can do with either conservation or on-site renewables to net yourself out to zero. So you can have off-site renewables, and there's kind of a different there's some different discounting factors for those if you have to use them. And so if you're not going for zero, which we would prefer everyone to go for zero, but we have this other certification tier in terms of the overall energy, where there's a finite target that you have to meet, and that is designed to be challenging but doable just with conservation measures, basically. And so in order to make that happen better, we added some nuance to it this time around for the residential. But even on this what we formerly called core tier, even on this regular tier, we're going to require electrification readiness. Okay, so we had set this idea of, an equal share per person for the overall source energy allowance. But we encountered a use case that could not do that. And that was basically buildings with a whole lot of studio apartments. And so it's somewhat of a consequence of the modeling protocol, that there's a certain fixed amount of plug loads that is assumed to happen per unit, and if you don't have very many people per unit, then that creates a lot of usage per person, or implies a lot of usage per person, which busted these studio apartment designs. So we looked through our study data from 2018 and came up with a correlation that basically gives that a break. So we backed off a little bit from the strict per person allowance, and so that's now kind of dependent on unit density. And you can see some examples here of the same design of a multifamily low-rise with different densities, 1 bedrooms, 2 bedrooms, and studios. And so for the more unit dense buildings, then the per person target is relieved a bit and is much more doable. Okay, so the same rule though applies to single family, and so you know, that does again somewhat back away from the strict per person allowance. So you know, if you do have less bedrooms, you get more of an allowance per person now, but you know, you can't. That's not unlimited. There's a range limit on that. So you can't just like keep increasing the floor area and get more source energy allowance. And so in this case, for this house, yeah, they had pushed it a little bit too far. I think the limit is in fact like 1,000 square feet per person of range limit adjustment on that. So these people would have to do something a little bit more still to in their one bedroom case to meet the limit. And just like in 2015, it's mostly, the idea is mostly to meet this with conservation, but there's a little bit of renewables that you can count, like solar hot water still works. Okay, so moving into the prescriptive path now. So this is sort of the overall flow chart or of our tiers or certification options. So we've got our performance path, which is based on modeling, PHIUS plus 2021 to that finite target, and then to 0 if you're going to 0. But if you're just doing a single family and you want to skip the modeling, the prescriptive path is available. And yeah, if there's anything about that you don't want to do, you know, you can fall back to the performance path. Okay, so we were asked for a chart of a grid of how this all works. So maybe I'll try and go quickly column by column here. So PHIUS plus 2021, that's the performance path with the finite source energy target. So again, we're modeling to meet our heating and cooling loads. We're modeling to meet our source energy target. And that source energy target now varies with unit density and occupant density, and only a little bit of renewables counts. Electrification wise, we're just requiring readiness on that basic tier. For moving to the right there, for our source 0, same heating and cooling targets, same modeling so slightly different modeling protocol for source energy, where everything's netted out on site and off site. And then electrification wise, you just can't do any fossil fuel combustion. For the prescriptive path, you know, since we're avoiding modeling, we have to spell out what are you going to do for all of your passive measures. What are you, and we're not modeling for overall energy either, so we have to spell out all the equipment efficiency measures you have to do. And again, there's no fossil fuel combustion there either. Okay, so there's several aspects to the prescriptive path. There's some additional limitations on the scope, in addition to just being single family. And then all the stuff that's sort of in green there is kind of, you can think of that as passive measures and supplementary requirements related to the passive measures. And then, like I say, we have to come up with rules or requirements for all of the mechanical and all the appliances and equipment as well. And so maybe the thing that's going to be least familiar is the requirements for compactness. We started out with just, you know, air tightness, R values, HRV, that kind of thing. But when we tested it on some past projects, you know, there were some like H-shaped buildings that annoyed us with their, you know, with their performance. It wasn't really as good as what we wanted. So we came up with some constraints on the design, architectural constraints to kind of enforce some compactness on the design. And so that consists of compactness in plan and compactness in section. So for compactness in plan, the idea is that we don't want strung out H-shaped or L-shaped or T-shaped buildings. So what creates those is so-called reentrant corners. And so we limit the sort of included area of those. So the cases on the left would sort of just meet the requirement, and the cases on the right are too strung out in plan. For compactness in section, the idea is that you should kind of have a consistent floor area from level to level, so that you're not doing, you're not popping up like towers, or leaving a whole lot of open to below that's cutting into your floor area. Right. So the idea is, so kind of the threshold that we set is around the idea of, if you had a 3-story, you could maybe make the 3rd story about half as big as the other 2, and it would just pass. But if you're trying to do something on the right layer, like a big popped up tower, that's too strung out. And similar there, yeah. There's one more compactness rule which prevents you from doing Z-shaped buildings in section, but yeah, we don't have a graphic quite for that yet. All right, so in addition to being single family, it can be attached or detached, but there are some additional restrictions on the scope. We don't want huge mansions, so we limited the ratio of floor area to bedrooms. Again, no fossil fuel combustion. We don't want to take too much moisture risk, so you can't have an indoor pool. And then, yeah, no natural draft fireplaces. That comes from indoor EPA, Indoor Air Plus. So so all of our prerequisites, our quality assurance, co-requisite programs still apply. The Energy Star certified homes, the Zero Energy Ready requirements, and the Indoor Air Plus requirements. And I've got the page counts there. So, all those checklists add up to some 40 pages of requirements, and our prescriptive checklist that we added adds about 6. And so for the passive measures, air tightness is super number 1 there. And we're cranking down on that. And on the performance path, we would let you get away with 0.06 CFM per square foot. But when we did all our cost optimization studies, the cost optimizer actually usually found it worth it to go tighter. So we tightened up on that. And in the regular program, sort of the preliminary blower tower test is optional, but we're requiring it for the prescriptive path. So you have to get your rater on board earlier. Solar protection, there's 3 things that are done for that. We limit the overall window to wall ratio and the concentration of glazing on any one facade. Fixed overhangs are required on south-facing windows in hot climates, and the solar heat gain coefficient of the windows is also limited in hot climates. We also have requirements to limit moisture risk at both windows and connections and main assemblies, and to avoid thermal bridges. All right, so there are requirements that are project specific, so that a lot of them are climate dependent, and some of them are building dependent. So for example, the lighting allowance depends on the square footage of the building. The hot water energy allowance is that depends on sort of the occupancy, the number of bedrooms. But there's a whole bunch of stuff which is climate dependent, and some of those things are location specific, and some of them are kind of are figured out zone by zone. Okay, so to give you, we were asked for to give a couple of for instances. So here's what. So we picked out 3 locations. So Austin, Texas, Vancouver, BC, and Duluth, Minnesota. And so you can see the main R values in the top there. And the window U value, that should be a maximum, I think, for U value. So the window, let's see, what do I want to say about this? Okay, so I'll go with the window. So the window U value requirement is based on a comfort principle. So we want to have windows that are good enough that they don't require heat under the window, or to avoid like draft at the ankle, basically. The window solar heat gain coefficient, I believe we just carried through on the zero energy ready requirements there. There's also a condensation resistance requirement on the windows and doors, and that involves 2 things. That depends on how humid the climate is, and also how cold it gets at the 99% design temperature. So you can see in Vancouver, BC, it's neither that humid nor that cold. So the condensation resistance requirement is low. But in Austin, it's pretty stiff because it's humid, and in Duluth, it's also pretty stiff because it's so cold. And then, in most climates, we don't require the fixed overhangs for shading, but in Austin, Texas, we would. So for the mechanicals, that's also slightly climate dependent. We've picked out an example here of if you're using an air source heat pump. There's sort of the requirements on the equipment efficiency are kind of relative to the category of thing that they are. So there's different thresholds for like ground source heat pump if you're going to use that. But basically, what's going on here is that it's asking for Energy Star most efficient 2020, except in the colder climates where we require the Northeast Energy Partners criteria, which sets a minimum on the CO, or minimum COP at 5 degrees outside. For the HRV, there are requirements on the winter, on the sensible recovery in the winter, and the total recovery in the summer. And the sensible recovery in the winter is again based on a comfort principle. That's trying to maintain a 60-degree delivered air temperature at, I believe, the coldest monthly average temperature. And then for coming up with the total recovery efficiency, that was based on a survey of how much dehumidification is needed, basically. So in climate zones where there's a lot of dehumidification needed, we require latent recovery. And then there's also a limit on the length of the ducts that connect to the outside, and that is based on like the building size, basically the number of stories and the square footage. So if you're wondering how we came up with those R values, you might remember that when we set our heating and cooling performance targets in 2018, we did a bunch of cost optimization on a bunch of study buildings to do that, and then fitted regression formulas to those to the performance of those optimized buildings to come up with the climate-specific target formulas. And basically what we've done is the same type of analysis, but for the R values instead of the overall performance. And so we did find good correlations for those. This is illustrating kind of the sensitivities of how that works for the wall R value. And so what that indicates is as the climate gets, as the heating degree days go up or the design temperature goes down, you have to beef up the wall R value. And also as your marginal electricity price increases, you know, it pays back better, right, to increase the insulation. So we're going to bump it up for that too. And that was a pretty good correlation. You know, statistics wise, it had a correlation coefficient of 0.88. But, you know, there is some scatter, you know, it doesn't fit perfectly. And so, you know, we took like the root mean square error of the fit, which happened to be 5.6, and just added that as a constant to the requirement to make it a more conservative. So we call that a conservative fit instead of a best fit is the idea there. Okay, so we have a workbook. So one thing I didn't mention yet is that we do allow some little performance trade-offs within the prescriptive path. You can do an overall UA. So if you don't want to meet the R values and the of the assemblies individually, you can meet an equivalent overall UA. And there's also a trade-off for the equipment efficiency, and that includes all of the builder installed lighting, hot water, and appliances, but not the heating and cooling stuff or the ventilator. So there's basically a workbook that's going to help out with these calculations, including, and you can see there's sort of hidden sections there on compactness that aren't filled out. We're going to add capability or calculation support for those things too. But yeah, there's already support in there for, like, you know, complying with your window condensation requirement. Okay. And so, yeah, please give us feedback on this. There are several pieces to it posted on the website. There's the full checklist and the calculator, which calculates the things that vary with climate or with building parameters. And then there's this assistant thing, which helps you with this the side calculations. And I think with that, we did have, I think we were asked for some leading questions. So maybe we could, I think that's the next one, right? Yeah. So here are some questions that we had. So do we still need CPHCs submitting these projects, or can the rater do it, kind of thing? So right now we have a number two. So we had that zero, you know, that zero tier for the performance path, but we don't have a zero tier for the prescriptive path. Is that a good idea or not? And you know, since we're not doing WFI passive modeling, that would have to be based pretty much on like the HERS score. So yeah, we're wondering if that's a good idea.